thanks a lot for inviting me here. It's really an honor to be here in Nepal. So thanks a lot to the organizing committee and chief guest. It's somebody was saying earlier. This is a small NOG. I don't think so. See, in this room here, this is actually a pretty big NOG, and I think it's really awesome to see how many people here come together. And as we said, this is all about sharing, and I want to share a little bit about like how we built our network, how we got there, the history behind it. Here we go. So, as you know, our network is pretty big. There's currently 1.9 billion users on Facebook alone. And as the chief guest was saying earlier, he wants people to use more than Facebook. We also have Instagram and WhatsApp on this platform. This is a lot of network traffic. And that's pretty unique challenges on getting that delivered to the end users. And that's what really matters most. I mean, you want to be able to use this at your phone right now when you want it. This map is actually quite nice to see. This is not actually showing our network. This is showing the people on our platform. This is connections between people. This is friendships between people that are illustrated on this map. You can see they go literally all across the globe. And this is a beautiful thing to see, and this motivates us to do what we're doing. So if you use Facebook on your mobile phone today, it has to connect to our network in some way, shape, or form. And this is really today about how we do this, why we're doing it this way, how we got there. How does Facebook work? Facebook is somewhat different from a lot of other OTT networks in that we have a mix of traffic, right? We have dynamic traffic, that's like your news feed, currently actual data that refreshes, has to be globally synced, all the likes somebody does on your page, on your pictures, that happens in real time, and that dynamically has to talk back to our network. And then on top of that, you have static traffic. That's more the traditional kind of CDN traffic. That's like this picture right there. That's a static element of the page. While the kind of update when it was posted and who liked it, that's dynamic. And that poses some somewhat different challenges than what some other CDNs have. So just want to go back in time and give you an idea how we started and how we got where we are today. This is 6 years ago. We literally had 3 data centers in the United States, and that was it. All that dynamic traffic had to go back to those. This graph illustrates the RTD you would see. And yeah, if you're in North America or if you're in Europe, that was pretty good. If you're over here, not so much. So this was something we really needed to solve. We wanted to give the users the best possible performance. So what do we do? Well, as a first step, let's have a look what the actual challenge here is, right? From a user in Asia, the nearest data center would be on the US West Coast. So you have about 150 milliseconds round trip delay. So that's the TCP connection alone is 150 milliseconds. On top of that, all of our traffic is encrypted. So you have the entire SSL, or nowadays TSL handshake. That's another 300 milliseconds. And then you have the actual HTTP GET to get the content delivered to your users. So you have 600 milliseconds pass before anything happens, basically. And that's obviously, that's over half a second. That's not what you want to see. So, as a first step, we built POPs around the world. As an illustration here, a POP in Asia. Say your end user is about 30 milliseconds away from that POP. That's already a huge improvement on the TCP session, right? So let's look at that example. So the TCP session, the actual SSL handshake, all happens within 90 milliseconds now compared to 450 before. That's pretty damn good. As the next step, the actual HTTP GET for the dynamic content, still has to go to the data center, but because that happens over an already established TCP connection between our POP and our data center, that's only a single round trip. So in the case of a static content for our example user in Asia, we're now down to 240 milliseconds compared to 600 before. So that's a big improvement already. So here, just illustrate the numbers again. We see like everything locally happens pretty quick, and then the end-to-end dynamic response is 240 milliseconds. Keep in mind, the static traffic can be served directly from the POP. That doesn't have to go back to our data center, so that will be even quicker. That will be within 120 milliseconds. So that's the first step in our journey there, and we built those POPs all around the world. The nearest ones to you are in Singapore and in Mumbai. As the next iteration of that, we took that one step further and we introduced caches. So now those caches sit inside your own network or your upstream's network, so they're a lot closer to you. We have a bunch of those in Kathmandu right here. Now, if your user requests static content, that only has to go to that cache that's right there. So this happens within 40 milliseconds now, instead of the 600 we had earlier. The dynamic content obviously will still have to go back to a POP, so that has to be synced in real time. We cannot do that on a cache, something that only happens once you can't cache. That's the same for like voice conversations or stuff like that. But I mean, the vast majority of the volume of your traffic is static, and that stays local now, that stays within a POP. So that's a huge improvement for your end user right there. Now, obviously the internet is evolving, right? It's like the content people use, the content people share changes a lot. If you go back probably, well, less than 10 years, the Facebook homepage was essentially text-based. You posted status updates and that was basically it. There was very little media in there. That evolved with people sharing a lot of pictures. And that's still happening today. I'm one of them. I'm sharing pictures like the one you saw earlier all the time. But more and more people actually share videos. I'm a bit old, I don't really do that much, but I'm definitely the minority. Videos are getting huge on the platform, and that's really where things are heading, and that's what drives traffic growth. I mean, if somebody shares a few hundred kilobit picture compared to a 50, 60, more than 100 meg video, that's a huge step change, and that obviously drives huge scaling challenges, and that's where the caches come in to keep that traffic as close as possible to you, to offload your international links and ensure good performance for that. Now, how do we make sure traffic gets where we want it to be? This sounds simple, it's actually not. If any of you dealing with networks will know that. The protocols in the network are not really designed for today's applications. BGP is a great protocol, but BGP looks at a